Hi everyone. Today we're going to study permutations. Let us define permutation. Permutation is an arrangement of items where order is taken into consideration. Let's go now to permutation formulas. And this is letter A. The number of permutation of n number of items taken R at a time is given by this formula. P of n of R. Take note that the symbol here, this is n factorial. So the formula is n factorial over the quantity n minus R factorial. And this n factorial is simplified into n times the quantity n minus 1 times the quantity n minus 2 up to it reach 3 times 2 times 1, and 1 is the last number. For example, if we have 4 factorial, this is equal to 4 times 3 times 2 times 1, and the final product is 24. By definition, take note that 0 factorial equals 1. Let us have example 1. How many 3-digit numbers can be formed from the numbers 3, 5, 7, and 9 if repetition is not allowed? Using this formula, let us now write P of 4 because there are 4 digits, namely 3, 5, 7, and 9, comma, and this is 3 because the required is 3-digit number. This is equal to n factorial now becomes 4 factorial over the n minus R is now 4 minus 3 factorial. Then let us simplify this 4 minus 3. We have 1 factorial. Simplifying further, the 4 factorial becomes 4 times 3 times 2 times 1 all over 1 factorial is also 1. And our final answer here is 24, which is the same answer in our previous example. Let's have example 2. How many 5-letter words, so this is with or without meaning, can be formed from the word liberty without repetitions? So our formula is P of 7, 5. The number 7 comes from the number of letters in the word liberty. And this 5 is the 5-letter word that is required in the problem. This is equal to the n factorial is 7 factorial over the n minus R is now 7 minus 5 factorial. And this 7 minus 5 is 2, and we will take the factorial. And this is now equal to the 7 times 6 times 5 times 4 times 3 times 2 times 1. That is for the 7 factorial all over. The 2 factorial is 2 times 1. We can cancel this 2 times 1, and there is 2 times 1 also in the denominator. So let us multiply 7 times 6 times 5 times 4 times 3, and the product is 2,520. These are the 5-letter words that we can form from the word liberty. This is our final answer. Let's have letter B formula of permutation, and it says the number of permutation of n number of items taken all at a time. So this is P of n equals n factorial. For example, how many ways can you arrange 5 different books on a shelf? So this is equal to P of 5, and that is equal to 5 factorial. And we know the 5 factorial is 5 times 4 times 3 times 2 times 1. And the product is 120. So we have 120 ways to arrange 5 different books on a shelf. This is our final answer. Example 2. How many 4-digit numbers can we make using the digits 3, 6, 7, and 8 without repetitions? So we write P of 4. There are 4 digits here and 4 because we require a 4-digit numbers. Simply means we are taking all the digits at a time. So this is equal to 4 factorial. So 4 times 3 times 2 times 1 equals 24. This is our final answer. Letter C. If there are n elements in a set and r sub 1 are alike, r sub 2 are alike, r sub 3 are alike, and so on through r sub k. The number of permutations can be found by this formula. In the numerator is n factorial all over the denominator r sub 1 factorial times r sub 2 factorial times up to the last factor, which is r sub k factorial. Let us have an example. Find the number of rearrangements of the letters in the word distinct. So using this formula, we will write here 8 factorial because the number 8 comes from the number of letters of the word distinct. Now in the denominator, we have 2 factorial times 2 factorial because both the letters I and letter T are repeated twice. So let us simplify this. The 8 factorial becomes 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 2 factorial is 2 times 1 times 2 factorial is another 2 times 1. To simplify further, we can cancel this 2 times 1 with this 2 times 1 here. And this number 2, we can cancel with number 4, and the number 4 becomes 2. And another number 1 is in the denominator that we can simply ignore. Now let us multiply 8 times 7 times 6 times 5 times 2 times 3. And the product is 10,080. And this is the number of arrangements. This is our final answer. Formula D is about circular permutation. Circular permutation is the total number of ways in which n distinct objects can be arranged around a fixed circle. This is the formula. The quantity n minus 1 factorial. Example, in how many ways 7 persons can be seated around a circular table. Our formula is here. We substitute the corresponding value. So we have the quantity 7 minus 1 factorial. So we have 6 factorial, and we can expand this into 6 times 5 times 4 times 3 times 2 times 1. And the product is 720. This is the final answer. Letter E. The number of permutations of n different objects taken are at a time where repetition is allowed is n raised to r. Example 1. How many three-letter words with or without meaning can be formed out of the letters of the word number, where repetition of letters is allowed? The word number has 6 different letters. So we have that n equals 6. Then we have 3-letter word. That means we're going to take 3 at a time. So r equals 3. Then our formula n raised to r. Substituting the values, and we simplify this into 216 words. Example 2. How many 4-letter words with or without meaning can be formed out of the letters of the word rose, where repetition of letters is allowed? The word rose has 4 different letters, so n equals 4. Then we need a 4-letter word. That means we will take all at a time. So r equals 4. Then our formula n raised to r. So 4 raised to 4. And we simplify this into 256. There are 256 words. Find the number of words with or without meaning that can be formed with the letters of the word letter A, Oman. This is a permutation of all items taken all at a time. P of n, comma n, that is equal to n factorial. There are 4 letters for the word Oman. So that is P of 4, comma 4, that is equal to 4 factorial. We can use our calculator to get the value, but we can show that by solution 4 times 3 times 2 times 1, and the answer is 24. Next, letter B, swimming. This is a permutation of all items taken all at a time, and some items are alike. This is our formula. There are 8 letters for the word swimming, so here is 8 factorial in the numerator. In the denominator, we can see that the letters M and I appear twice. That corresponds to 2 factorial times 2 factorial. For letters that appear once, no need to write 1 factorial. Then we simplify this. The 8 factorial is 40,320. 2 factorial is 2 times 1, that is 2. 2 factorial is also 2 times 1, that is 2. In the denominator, the product is 4. Then 40,320 divided by 4. That is 10,080. Problem 2. How many 4-digit numbers that are divisible by 10 can be formed from the numbers 3, 5, 7, 8, 9, 0, such that no number repeats. This is a permutation, but we will use the multiplication principle. We need 4-digit numbers. Let's have 4 blanks here to represent the number. Note that there are 6 digits given, namely 3, 5, 7, 8, 9, 0. Also, a number that is divisible by 10 ends in 0. That means if we put the numbers, the last number here, there is only one option. That is 0. So we write it here. Of the 6 digits given, the number 0 sits on the last. So, on the first blank, only 5 digits can be optioned. So we write here 5. After putting one number here and another number here which is 0, so 2 numbers are already seated. That means in this blank, only 4 options are there. And in here, there are 3 options left. Then we multiply 5 times 4 times 3 times 1. The answer is 60 numbers. Problem 3. How many ways are there to construct a string of 3 digits if numbers A cannot be repeated? This is a permutation, and we consider the 10 digits from 0 up to 9. Note that this is a permutation of 10 items taken 3 at a time. So that is P of 10, 3. The formula is 10 factorial all over 10 minus 3 factorial. Actually, we can get the value from the calculator, the permutation of 10 taken 3. By showing the solution, we have this 10 factorial all over 7 factorial. Then we expand this 10 factorial into 10 times 9 times 8 times 7 factorial all over 7 factorial. We can cancel this 7 factorial in the numerator and denominator. Then we simplify 10 times 9 times 8. The answer is 720 numbers. Letter B. How many ways are there to construct a string of 3 digits if numbers can be repeated? We consider the 10 digits also by permutation, and this is about multiplication principle. We have 3 blanks here representing the 3 digits. On the first blank, there are 10 options. On the second blank, since digits can be repeated, there are 10 options also. On the third blank, 10 options again. Then we multiply 10 times 10 times 10, and the product is 1000 numbers. Problem 4. Fatima bought 20 plants to arrange along the border of her garden. How many distinct arrangements can she make if the plants are comprised of 6 tulips, 6 roses, and 8 daisies? This is a permutation of all items where some items are alike. So this is our formula. Substituting, we have 20 factorial since we have 20 plants total all over 6 factorial times 6 factorial times 8 factorial. We can expand this into like this, 20 times 19 going down up to 8 factorial. We show the 6 factorial into like this, then we keep 8 factorial same. We can cancel the 8 factorial from numerator and denominator. Look at this 20. We can cancel this with a 5 and 4 below. What about this 18? We can cancel this by the 6 and 3. And this 16, we can cancel by 2, 4, and 2. Next is 15. We can cancel by 5 and 3. Then this 12 cancel with 6. Only 2 will remain after 12. Then we multiply 19 by 17, by 14, by 13, by 2, by 11, by 10, by 9. Finally, the answer is 116,396,280 arrangements. Six candidates are called for an interview to fill 4 posts in an office. Assuming that each candidate is fit for each post, determine the number of ways in which first question, first and second post can be filled. We have this notation: permutation of 6 taken 2 at a time. Or we have this notation, P of 6, 2. Then we substitute into our formula. This is 6 factorial over the quantity 6 minus 2 factorial. We simplify the denominator to be 4 factorial. Then we expand this 6 factorial into 6 times 5 times 4 factorial. We can cancel the 4 factorial respectively. Then 6 times 5 is 30 ways. This is the answer for the first question. Second, first 3 posts can be filled. So by notation, we can write permutation of 6 taken 3 at a time. Or we can use the symbol P of 6, 3. We substitute now the values. So we have 6 factorial over 6 minus 3, then factorial. The denominator becomes 3 factorial. Then we expand the 6 factorial into 6 times 5 times 4 times 3 factorial. Then we can cancel the 3 factorial respectively. We multiply now 6 times 5 times 4. Finally, the answer is 120 ways. Third question, all the 4 posts can be filled. So we can show 6 permutation taken 4 at a time, or our notation P of 6, 4. We substitute the values in the formula, 6 factorial over the quantity 6 minus 4, then factorial. The denominator becomes 2 factorial. Then we expand the 6 factorial into 6 times 5 times 4 times 3 times 2 factorial. We cancel now the 2 factorial. Then we multiply 6 times 5 times 4 times 3. Finally, the answer is 360 ways. Problem 6. How many words with or without meaning can be formed from the letters in the word maths, assuming no letter in the word is repeated? If, number 1, 4 letters are used at a time. We have here 5 different letters for the word maths. So that means by permutation, we have 5 taken 4 at a time. By our formula, we have now 5 factorial over 5 minus 4, then factorial. The denominator becomes 1 factorial. This 1 factorial is simply 1. And the 5 factorial is 5 times 4 times 3 times 2 times 1. And finally, the answer is 120 ways. Second question, all letters are used at a time. That means permutation of 5 taken 5 at a time. In this case, we can simplify our formula into 5 factorial. We know that 5 factorial equals 5 times 4 times 3 times 2 times 1. And the product is 120 ways. Third question, all letters are used at a time, but the first letter is either A or S. Note that if the first letter is either A or S, then the two letters can be arranged in two ways, and the remaining four letters can be arranged in permutation of 4 out of 4 ways, just like this. Then this P of 4 out of 4 is 4 factorial. We expand this 4 factorial into 4 times 3 times 2 times 1. And the product is still to be multiplied by 2. So finally, we have 48 ways. Hi everyone. Today we're going to study combinations. Let us define combination. A combination is a selection of all or part of a set of objects without regard to the order in which objects are selected. This is our formula. The number of combinations of n objects taken R at a time is this. We're going to use the symbol NC sub R. And this is equal to the fraction where the numerator is n factorial and the denominator is n minus R, then factorial multiplied by R factorial. Take note, the number of combinations of n items taken all at a time is 1. Let us see some examples. Example 1, compute letter A, combination of 5 items taken 3 at a time. Letter B, combination of 7 items taken 3 at a time. First, let us write our formula. Let us begin with letter A problem. 5C3 equals, using our formula, this is 5 factorial over the denominator 5 minus 3, then factorial, times 3 factorial. First, let us simplify the expression in the grouping symbol. The 5 minus 3 becomes 2. And then let us simplify the factorials. In the numerator, we have 5 times 4 times 3 factorial. In the denominator, the 2 factorial becomes 2 times 1. And the 3 factorial, we will keep it as is. Because we can see here that we can cancel this 3 factorial and the 3 factorial in the numerator. There we go. Simplifying further, the numerator becomes 20 over the denominator is 2. And the quotient will give us 10. This is the combination of 5 items taken 3 at a time. Let's proceed with problem B. 7 items taken 3 at a time. This is equal to 7 factorial over 7 minus 3, then factorial times 3 factorial. Let us simplify. The 7 minus 3 will give us 4, and then let us simplify the respective factorials. On top, the 7 factorial becomes 7 times 6 times 5 times 4 factorial. In the denominator, we keep the 4 factorial as is, and then let us expand the 3 factorial as 3 times 2 times 1. We can cancel the 4 factorial in the numerator and in the denominator respectively. And then simplifying further, the numerator gives us 210 over the denominator, which is 6. So 210 over 6 equals 35. This is the combination of 7 items taken 3 at a time. These are the final answers. Let us see example 2. In how many different ways can a student select to answer 5 questions from a test that has 7 questions if the order of the selection is not important? For our solution, since the order is not important, it is a combination problem. Thus, we write combination of 7 items taken 5 at a time. Using our formula, this is now equal to 7 factorial over the denominator 7 minus 5 factorial times 5 factorial. Let us simplify the 7 minus 5. This is now 2. And let us now simplify the respective factorials. Our numerator can be written now as 7 times 6 times 5 factorial over the 2 factorial is now expanded into 2 times 1 times the 5 factorial. We will keep it as is because we can cancel the 5 factorial in the numerator and in the denominator. There we go. So in the numerator, we have now 42 over the denominator, which is 2. And the quotient will give us 21. This is our final answer, where 7 items is taken 5 at a time. Let us see example 3. How many line segments can be drawn by connecting any 2 of the 6 points that lie on the circumference of a circle? For our solution, since the line that goes from point A to point B is the same as the one that goes from B to A, this is a combination problem. It is a combination of 6 objects taken 2 at a time. Therefore, we can write 6C sub 2. Using our formula, this is now equal to 6 factorial over the denominator 6 minus 2, then factorial, times 2 factorial. Let us simplify first. The 6 minus 2 will give us 4. Then let us now simplify the respective factorials. Our numerator can be written as 6 times 5 times 4 factorial. In our denominator, we will keep the 4 factorial as is. Then let us simplify the 2 factorial into 2 times 1. We can now cancel the 4 factorial in the numerator and in the denominator. So here we go. And in the numerator, we have now 30 over the denominator, which is 2. And the quotient will give us 15. This is the final answer. Let us see example 4. There are 10 people at a party. If they all shake hands, how many handshakes are possible? In this case, we note that between any two people, there is only one handshake. It means to say, we're going to write combination of 10 people taken 2 at a time. Using our formula, we have now 10 factorial over the denominator 10 minus 2 factorial times 2 factorial. Let us first simplify the 10 minus 2. It will give us 8 factorial. Then let us now simplify the respective factorials. The numerator becomes 10 times 9 times 8 factorial. Over the 8 factorial, we will keep it as is. And let us expand the 2 factorial, which is now 2 times 1. We can now cancel the 8 factorial in the numerator and in the denominator respectively. So now, we can now simplify our numerator to be 90, that is 10 times 9, over the denominator, which is now 2. 90 divided by 2 is equal to 45. So it means there are 45 possible handshakes in a party of 10 people. This is our final answer. Example 5. In how many ways can you select a committee of 3 students out of 10 students? This is a combination of 3 out of 10 students. We have this formula for combination. Let us now substitute the values. This is combination of 10 taken 3 at a time equals 10 factorial all over 10 minus 3 factorial times 3 factorial. Let us simplify. This 10 minus 3 becomes 7 factorial. Let us expand this 10 factorial. It becomes 10 times 9 times 8 times 7 factorial. We stopped here because there is a 7 factorial below that we can cancel later. This 3 factorial will show us 3 times 2 times 1. Let us now simplify by cancellation. 7 factorial is cancelled out. Then 10 by 2, 10 becomes 5. Then 9 by 3 are cancelled and 9 becomes 3. So we multiply 5 times 3 times 8. We get 120 ways. Example 6. How many ways can a committee of 3 freshmen and 4 juniors be formed from a group of 8 freshmen and 11 juniors? To form the committee, we choose 3 freshmen from 8 and 4 juniors from 11. So the total number of committees will be combination of 8 taken 3 at a time multiplied by 11 taken 4 at a time. We substitute the values using our formula. Here we have 8 factorial all over 8 minus 3 factorial times 3 factorial. On the other combination, 11 factorial all over 11 minus 4 factorial times 4 factorial. Then we expand 8 factorial to be 8 times 7 times 6 times 5 factorial. All over, this 8 minus 3 becomes 5, then factorial. The 3 factorial here we show as 3 times 2 times 1. Then the other combination. The 11 factorial we expand as 11 times 10 times 9 times 8 times 7 factorial. We stopped here because we see that 11 minus 4 is 7, then factorial. We express this 4 factorial now into 4 times 3 times 2 times 1. Let us simplify first this fraction. We can cancel the 5 factorial respectively. Then we cancel this 6 by 3 times 2. Next, the other fraction. We cancel 7 factorial respectively. We cancel 8 by 4 and 2. Then we cancel this 3 by the 9, and the 9 becomes 3. Let us now simplify our fractions. In the first fraction, this is now 8 times 7. That will be 56 times 11 times 10 times 3. That is 330. Then we multiply the two numbers, and the product is 18,480 ways. Hi everyone. Today we're going to study inclusion and exclusion principle. The principle of inclusion and exclusion is an approach to find the number of elements in the union of the sets. In this video, we shall discuss number 1, addition rule for 2 sets. Number 2, addition rule for 3 sets. The number of elements in the union of two finite sets A and B. This is our notation. The formula is here. So the union of A and B is equal to number of elements in A plus number of elements in B minus number of elements in the intersection of A and B. Using Venn diagram, the union of two finite sets are given here. Example 1. In a discrete mathematics class, every student is a major in computer science or mathematics or both. The number of students having computer science as a major, possibly along with mathematics, is 25. The number of students having mathematics as a major, possibly along with computer science, is 13. And the number of students majoring in both computer science and mathematics is 8. How many students are in the class? we let capital C equals students majoring in computer science. We let capital M equals students majoring in math. Using our addition rule formula, we will do like this. The union of C and M is equal to the number of elements in C plus number of elements in M minus number of elements in the intersection of C and M. Substituting the values, we have now 25 for the number of elements in C plus 13. This is the number of elements in M minus 8. This is the number of elements in the intersection of C and M. Simplifying the three numbers, the answer now is 30. Example 2. Among 50 patients admitted to a hospital, 25 are diagnosed with pneumonia, 30 with bronchitis, and 10 with both pneumonia and bronchitis. Determine, number 1, the number of patients diagnosed with pneumonia or bronchitis, or we say both. First, we denote capital P as the patients with pneumonia. We let capital B with patients with bronchitis. Using our addition rule formula, it becomes like this. The elements in the union of P and B is equal to number of elements in P plus number of elements in B minus number of elements in the intersection of P and B. Substituting the values, we have now 25. This is the number of elements in P plus 30. This is the number of elements in B minus 10. This is the number of elements in the intersection of P and B. Simplifying our integers, the answer is 45. Let us copy this answer opposite problem I. Then we go to problem 2. The number of patients not diagnosed with pneumonia or bronchitis. Our formula is total number of patients minus the number of elements in the union of P and B. The total number of patients is 50 minus 45. This is our answer from problem 1. So the difference is 5. This is the answer for problem 2. Example 3. Every student in a class has registered either in mathematics for computing or in programming or in both the courses. How many students are there in the class? If 38 students have registered in mathematics for computing, 23 students in programming, and 7 students in both the courses. We let M be the number of students in mathematics for computing. Let P be the number of students in programming. We can write our Venn diagram, then we write the numbers based on the given. The total number of students that we need is the union of M and P, and we need the final number. And we have this formula. The number for M plus the number for P minus the number for the intersection of M and P. Then we do the substitution. We have this 38, that is the number of M, plus the 23, that is the number of P, minus 7 students, which is students who studied both the courses. Finally, the answer is 54. The number of elements in the union of three finite sets, A, B, and C. This is our notation. The cardinal number of the union of A, B, and C, and the formula is here. It's a long formula. So the union of three finite sets equals the number of elements in A plus number of elements in B plus number of elements in C minus the number of elements in the intersection of A and B minus the number of elements in the intersection of B and C minus the number of elements in the intersection of A and C plus the number of elements in the intersection of the three sets. Using the Venn diagram, these three circles represent the three sets A, B, and C respectively. The small space here represents the A intersect B. The small space here represents the B intersect C. And the small space here represents A intersect C. This space in the center is what we call the intersection of the three sets. Example 1. A survey of 100 students with respect to their choice of ice cream flavors, vanilla, chocolate, and strawberry, shows that 50 students like vanilla, 43 like chocolate, 28 like strawberry, 13 like vanilla and chocolate, 11 like chocolate and strawberry, 12 like strawberry and vanilla, and 5 like all of them. Find the number of students who like number 1, vanilla only. Second, chocolate only. Third, chocolate but not strawberry. Fourth, chocolate and strawberry but not vanilla. And the last problem says, let us find the number of students who do not like any of these flavors. First, it's better we write our Venn diagram. Let's have three circles representing the number of students who like the flavors chocolate, vanilla, and strawberry respectively. There are 100 total students. Let us fill in the numbers in here. First, let us fill in the number in the middle. The problem says there are 5 students who like all the 3 flavors. So we write it here. Next is the space here. The problem says there are 13 students who like vanilla and chocolate. However, in the middle, there are 5 students already listed. So what we have is 13 minus 5 is 8. That is why we wrote 8 here. Next is this space. The problem says there are 11 students who like chocolate and strawberry. But in the middle, we have 5 already. So 11 minus 5 is 6. Then we have the space here. We write here 7. The problem says there are 12 students who like strawberry and vanilla. But since we have 5 already in the middle, that is 12 minus 5 is 7. We are now to start finding the number of students who like vanilla only. the problem says there are 50 students who like vanilla. And this is the circle for vanilla. What we will do here is to write the total number of students, that is 50, minus the three numbers here, minus 8, minus 5, minus 7. And the answer is 30. It means there are 30 students who like vanilla only. And we write the number 30 here. Second, find the number of students who like chocolate only. In our problem, it says that 43 students like chocolate flavor. So what we're going to do, we're going to write 43 minus the three numbers here. So we write minus 8, minus 5, minus 6. To simplify this, the total is 24. It means there are 24 students who like chocolate only. Then let's have number 3 problem. Students who like chocolate but not strawberry. Look at our circle for chocolate and the circle for strawberry. To answer the third problem, we are going to write here 24 plus 8. And the sum is 32. There are 32 students who like chocolate but not strawberry. Before we go to problem number 4, let us complete our diagram here. What about those students who like strawberry only? In our problem, there are 28 students who like strawberry. We're going to copy this 28, then we will subtract by the three numbers here, minus 6, minus 5, minus 7, and the answer is 10. We will write number 10 in this space. We will now proceed with problem number 4. Find the number of students who like chocolate and strawberry but not vanilla. Look at our diagram here. We can see one number, that is 6. And this is the answer for problem number 4. There are 6 students who like chocolate and strawberry but not vanilla. Then problem number 5. Find the number of students who do not like any of these flavors. There are 100 total students. What we're going to do is to write this 100 minus the sum of all these numbers in the diagram. So that is 24 plus 30 plus 10 plus 8 plus 7 plus 6 plus 5. Simplifying this, we have 100 minus 90, and the difference is 10. There are 10 students who do not like any of these flavors. Example 2. A total of 1,232 students have taken a course in Spanish. 879 have taken a course in French. And 114 have taken a course in Russian. Further, 103 have taken courses in both Spanish and French. 23 have taken courses in both Spanish and Russian. And 14 have taken courses in both French and Russian. If 2,092 students have taken a course in at least one of Spanish, French, and Russian, how many students have taken a course in all three languages? First, let us assign values. Let capital S equals set of students who have taken a course in Spanish. Let capital F be the set of students who have taken a course in French. Let capital R be the set of students who have taken a course in Russian. Then let us collect values. The number of elements in S equals 1232. Number of elements in F equals 879. Number of elements in R equals 114. Then, the number of elements in the intersection of S and F equals 103. The number of elements in the intersection of S and R equals 23. The number of elements in the intersection of F and R equals 14. The number of elements in the union of S, F, and R equals 2092. Then let us write our formula. Substituting the values in the formula, we have now like this. When we simplify this formula, we will be able to get the value of this variable. That is, the number of elements in the intersection of the three sets S, F, and R. Simplifying now the integers in the right side, we have now this 2085. Solving for this value, we're going to transpose this 2085 to the left side. Simplifying further, it becomes like this. The number of elements in the intersection of S, F, and R equals 2092 minus 2085. And the difference is 7. This is the number of students who have taken a course in all three languages. This is the final answer. Example 3. Among a group of students, 50 study physics, 35 study chemistry, and 25 study mathematics. If 9 of these students study physics and chemistry, 5 students study chemistry and mathematics, 4 students study mathematics and physics, and 3 students study all the 3 courses. Find the number of students in the group. We let P, C, and M denote the students studying physics, chemistry, and mathematics respectively. We need this value, the total number of students. That means the number for the union of P, C, and M. And we have this formula. Then we substitute the values. We have this 50 students who study physics plus 35 students who study chemistry plus 25 the students who study mathematics, then minus 9, these are the students who study both physics and chemistry, minus 5, these are the students who study chemistry and mathematics, minus 4, these are the students who study mathematics and physics, plus 3, the students who study all the 3 courses. Finally, the answer is 95.